Okay, let me give you a quick definition. Average value. Okay. And this is kind of a weighted average, right? So if you want to know, for example, this question, like, what's the average of f of x and y over some region R? What do they mean by this? They mean like take the biggest f is, take the smallest f is, subtract, and divide by 2? Or why would that be a coarse measurement?
You'd have a really low function except for one point that's like a billion.
Yeah, perfect. Right, so what do they mean? They mean the average weighted by by almost volume, right? By area. You guys see that? So I want to find out what the volume is, right? And then
Divide by the area.
perfect, divide by the area. So how would I find out what the volume is? What's the volume under F over R? Okay, good. I need a dA or a dx dy, right? And I probably want to do that to F. And then what other symbol do I need here? Yeah, I better have an integral so I know what to do with dA, right? Because otherwise I have no idea. So I want to integrate over R. So right now, what's this thing? Perfect. This is the volume under F over, or maybe, yeah, really, over slash above slash however you think about this, over R, right?
This could be 0 though.
Yeah, so of course this could be 0. And what do I want to do with this thing? So this is a volume, right?
Okay.
Yeah, and then I want to take this divided by the area, so I'm going to multiply by 1 over area of your region R, right? Notice this only makes sense, right, when the area has some, or when the region has some area in it. You guys see that? Doesn't really make any sense for me to talk about the average value of a function of two variables over something that doesn't have any area.
Like a line or something.
Yeah, like over a line or over a point, right? We'll have some tools for that later, and I'm sure you guys could probably come up with some tools that would work, right? But this one, right, works with areas. How would I do this if this was a function of 3 variables?
dv.
Yeah, okay, so I'd move to dv, right? I'd still do the integral over, yeah, I need like a bigger rectangle, right?
So like a
Be shape,
prism.
right?
I think omega is usually standard, but whatever, right? Pick a frickin' variable. Phi was fine. The only reason I'm staying away from angle variables is that we're going to use them in spherical.
We could use mu.
Mu is fine. W, V, R, right? Calling it R would be fine. I just need to note whether it's 2 or 3 dimensional. And then, what would you put in here?
F of x, y, z.
F of a couple more variables, right? X, Y, and Z. And then what am I going to do 1 over here?
Volume.
If you wanted to do this in 27 dimensions, how would you do the same thing?
Cry.
How would you write down this statement in like lots of dimensions?
F of x, y, z, a, b, c, d, f, g, y.
Yeah, you'd write down, okay, f of x1, x2, and so forth to xn, right?
Yeah.
D, whatever.
D,
One less than the space.
right?
Yeah.
I mean, I'm just making notation up. And that's really what I would expect you guys to do, right? Really, this thing, right? if I had to think about it, is dx1, dx2, dx3, right?
Yeah.
You guys see that? So in this case, right, my dv is dx, dy, dz. In this case, of course, it's dx1 through dxn. And then I'd integrate over
Super omega.
The same, the
Super
the dimensions minus 1.
I'm going to go with mu. Still was pissed that I didn't last time. And then I'm going to do
On the right.
multiply by
Oh.
1 over.
W. Oh,
Volume of
G. N
volumes.
minus V to N
Yeah, I didn't have a
Your-
word
your
for
weird
this, right?
definition of volume.
minus. Yeah.
All the dimensions multiplied by each other.
Weird. Volume.
Right?
Yeah.
Traditionally, this would be called hypervolume, but who cares, right? It's just whatever you mean by take the volume of the whole thing. And how would you find the volume of the whole thing if you didn't have something nice and square? If it was rectangular, right, you just multiply the length times the width times the height times the next one times the next one times the next one until you got to the end, right? If you got a nasty one, you'd integrate 1 over the volume, right? Or over the shape. Cool.
Quick tangent. I never really researched this. Why did they start with X, Y, and Z on the planes? Why didn't they do A, B, C, per se?
Because the Pythagorean theorem took those already.
Actually, I think it more
To be honest, I don't have a good answer for that question.
coordinate axis, just standard X, Y, Z.
They just picked them.
Ask Descartes.
Yeah, I mean,
It's probably
I
Euler.
mean, like, they're least likely to be any
standardized, like,
number
everything.
to look like a number.
He did that like after that.
I have no idea.
So it's like